Hello and welcome to this Advantech webinar with Node Robotics and Orbbec, titled Fusion of Technologies for AMRs. My name is Michelle Mooney and I'm the Deputy Editor of Robotics and Automation magazine. I will be moderating today's discussion with our guests. We are thrilled to bring together a panel of experts who will share their expert insights and answer your questions. Remember that there is a live question and answer box where you can submit questions throughout the entire webinar, which will be presented to our speakers today at the end. Let me start by introducing our fantastic speakers. Giovanni Faravelli, Business Development Manager Europe at Advantech. Karthik, EMEA Sales and Operations Director at Orbbec. And Stefan de Laukin, CEO of Node Robotics. Before our speakers give a little background for themselves, we are launching into a quick poll to understand who's in the room and what you're most interested in learning today. Poll, please. During the technology evaluation phase of your AMR or AGV, where do you or your company spend the most time? Picking the right compute, picking the right sensor suites, picking the right software suites, all three, or something else? And now I will let our speakers introduce themselves while the audience responds to the poll. Giovanni, Karthik, and Stefan, over to you, please.
Thank you, Michelle. Hello to everyone. So about me, almost 15 years with Advantech. I started as a key account manager in the embedded IoT business unit. Then I led the Italian sales team for more than 6 years. And 2 years ago, I started a new challenge as a BDM Europe for robotics. Please, the next one.
Karthik.
Yeah, thank you. Thank you for having me here. It's an absolute pleasure and honor to share it with Giovanni and Stefan. So my name is Karthik. I'm based in Munich. I spent about close to 2 decades at Intel Germany, where I was in R&D as well as in sales. And these days, I'm here to set up and run the business of Orbbec for Europe, Middle East, and Africa. Yeah. Over to you, Stefan.
Thanks, Karthik. Pleasure to be here. I'm Stefan. I'm the CEO and co-founder of Node Robotics. I have 15 years background in mobile robotics, autonomous driving, started in research, academia, working for BMW and Fraunhofer, and then since 5 years now, I'm running Node Robotics as CEO, where we focus on HEV AMR software.
Thank you. Now we should have the results of the poll. Thank you for taking a moment to share that. It helps us tailor the conversation to what matters most to you guys. Okay, so 14% said picking the right compute, 10% said picking the right sensor suite, 7% said picking the right software suite, and a lot of you, 52%, said all three, and 17% said something else. Thank you guys very much for interacting with the poll. Now we will begin with today's presentation, starting with Giovanni. So Giovanni, over to you.
Yeah, so again, hello to everyone, participant at this webinar. It's my pleasure to give you, again, an introduction about Advantech, our company, and our tailored solution for autonomous mobile robots. As I said, my name is Giovanni Faravelli, so responsible in Europe about business development in robotics and also agri-tech sectors. Next page, please. Before to go into product specs, I think it's important to spend a few words about Advantech, a company founded in the 1983, so more than 40 years ago. We are a worldwide leader about development and production in our own manufacturing sites of embedded computing and industrial PCs, aimed to serve different market segments and related applications, using a flexible go-to-market, key accounts for direct sales approach, channel partner and focus system integrators, and also online sales. 2024 result was quite close to 1.9 billion. We are a global company, so with rich infrastructure offering local service in sales and technical support. Our broad product portfolio is based on main silicon vendors architectures, and these elevate our brand to have 41% market share in the industrial PC market. Last but not least, our company's certification witness our continuous investment to stay in a relevant position in our sector. Next page, please. Over the years, we grew our business in many different markets, and we become leaders in some verticals, such as industrial automation, gaming, transportation, and medical, for example. But we created a new product division, our headquarters in Taiwan, focused on robotics, roughly 3 years ago. So I think that we can all agree about future massive implementation of robotics in many different industries. In these pictures, you see something that is already happening, like carrier AMR or autonomous lifter in logistics and manufacturing, service robot in hotel or restaurants, petrol robots for public surveillance or monitoring in harsh environments, for example, delivery robot for public personal services, drones in agriculture, but also other kind of application, and the definitive cleaning robots. We see already a strong demand here. And humanoid, also for many kind of applications to replace humans in intensive and repetitive tasks. Next page, please. In today's webinar, I restrict the focus mainly on one controller for robotics based on NVIDIA technologies, well appreciated by developers since it delivers an easy hardware and software integrations, rich IOs, and high AI inference performance. Next page, please. So product name is AMRs100, based on Jetson AGX Orin. In general, data acquisition from sensors in order to enable perception and localization are vital for an autonomous mobile robot. For this reason, we have integrated a rich IOs like USBs, Ethernet ports, and up to 8 GMSL2 camera support. So we ensure support for LiDARs, radar sensors, useful for mapping and safety reason, but also serial port, digital input-output, and dual CAN bus for motion control. So wireless connectivity is also key for mobile robots, where we can integrate Wi-Fi 6 and 7 and 4G, 5G connectivity using our own M.2 add-on modules. Really appreciated by our customer, the integrated IMU sensors, very important to deliver orientation information to ensure reliable and precise robot movement. So reliability is, of course, key aspect, and we design and carefully validate our computing solution against high-level shock and vibration, and also wide operating temp, wide power inputs. So make the AMRs100 the ideal controller for robot manufacturer. Next page, please. AMRs100 is built around a standard NVIDIA module, and we decided to create standard part numbers using non-industrial SKUs due to lower power consumption and also price positioning. That's important. You can see here the configuration available for standard part numbers and also part numbers for carrier board, GMSL daughter boards. You will better understand in the next slide. Next slide, please. We designed it so the AMRs100 not only as off-the-shelf solution, but also to meet customization demand from customers. This is by project, of course. For this reason, the product is fan-based, and apart from the NVIDIA Orin AGX module, the carrier board, GMSL board, chassis, and antenna position are customizable. Next page, please. In this slide, you can have a better view of the IOs, connector placement, dimension, and internal view of this compute unit. Next page, please. As I said, by project, we can provide a number of customization services from electrical point of view, like power input, connection IO adjustment, and initial control modification. Thermal design, we can engineer a thermal solution in order to have a passive cooling. Mechanical, we can support shock and vibration required by customer and its specific application, and IP grade as well. Next page, please. So reliability is a key principle in Advantech design. We take in strong consideration the kind of environment the AMR has to operate. Our project managers used to have a close cooperation with robot OEMs engineers to ensure our compute unit meet environmental challenges. As I said, about operating temp, shock vibration, thermal dissipation, IP grade, and in case optional conformal coating, but also safety measures like IO ESD protection and the eFuse USB protection, and the reset function in case USB sensors hangs, overcurrent protection, integrated TPM, and also secure boot. Next page. But I'm really excited to show you our new product line that we will have very soon, so based on NVIDIA Ring again. But the main difference compared to the AMRs 100 are that we will have a GX, but also an X version. Fanless systems, and also we can offer board level version for customer having very limited space for integration of the compute unit. This product line comes from an autonomous system and robotics product division, totally focused on tailored controllers for robotics. I won't go in detail line by line, but the most important thing is that as Advantech, we can offer a product scalability, helping our customer to find the best compromise, price, performance, and features. Next page, please. Let me quickly introduce two more slides in order to make more complete our AMR controller offering. Wi-Fi modules. An AMR must operate with active connectivity. And you can see an example of modules compatible with NVIDIA platform. This is an Advantech product line where we can grant longevity, global certification, and technical support. And by project, we can also design specific antennas. Next page, please. So back to the AMRs 100 controller. From software point of view, we can pre-install Ubuntu 22.04 OS, for example, and latest Jetpack as option. This interesting software tool named Device On that manage connected devices remotely and provide centralized management features like device real-time hardware software status monitoring and management, device firmware software over-the-air update, so the OTA function, and container management function to deploy, monitor, and manage edge AI. So many of our customers, not only robotics, are using with strong satisfaction this Advantech software tool. Next page, please. Robotics is a complex and rapidly evolving sector, and no one company has the skill to cover all the technology aspects to build an autonomous mobile robot. For this reason, it's key for our company the creation of an ecosystem technology partners. I will now hand the floor over to our partners. Next page, please. Orbbec, high-tech camera manufacturers, and Node Robotics, modular software solution designed specifically for mobile robots. Next page. Okay, thank you. This is the end of my, let's say, presentation, but just last message, please visit us at the event Vision Robotics and Motion in Netherlands, June 11-12, Dagenbosch, and the Automatica from June 24-27 in Munich. Thank you. Thank you again.
Thank you so much, Giovanni. I just have two questions for you. Why should an AMR manufacturer select Advantech AMR controllers?
Well, because I think that in general, I mean, our organization is really well structured to support customer projects. This is in general. So, of course, product quality, reliability are essential aspects, as I said during my speech. But we believe that also the scalability, that's very important. So, and thanks to our broad product portfolio and consult support in the selection stage, create a winning partnership to overcome any hurdles during the development and integration phase.
When you talk about scalability, what do you mean exactly, and what is the value for your customers?
We see a very fragmented demand in this moment from robotics customers and a diversified approach to the hardware technologies from customers, engineering departments. As Advantech, we are premium partners of major silicon vendors And we are I think, in a unique position in order to offer standard or customized computing platforms, ranging from computer on modules to single board computers to compact box PCs and more. So moreover, our product division, Autonomous System and Robotics, we can offer really tailored AMR controllers with the right features and also sensors integration services. I really believe that we can help our customer to find the best, again, the best compromise, price and performance.
Thank you very much, Giovanni, for your presentation. Now we will hear from Karthik from Orbbec. So whenever you're ready, Karthik, over to you.
Yep, I think I'm ready. So thanks, Giovanni, for handing it over. So folks, I think I'll have about 10 to 15 minutes. I have 5 slides. I mean, the intention here is to get maybe 50 to 60% of the message from the slide to you folks. So I simply recommend you to maybe screenshot the slides if you want, and then you can always reach out to us offline, right? So this is sort of the way we're going to do this, right? So 5 slides, but there's like 3 sections. So I'm going to cover what's going on in the vision world about Orbbec, and then what is it that we have to do with Advantech, because there is no free lunch. So that's the part where I'm going to talk a bit more about the fusion part between what we did with Advantech, and then Stefan is going to further give you more insights, right? So next slide, please. Okay, so cameras, it's all about triangulation, mathematics, and playing with light. So that's what it's all about. So at the very top level, I mean, there are 3 ways in which you can actually basically estimate depth, and this is what we see here on the slide. On the left, there's something called stereo-based techniques, and then there's structured light, and then there's time of flight. So 3 different ways, each have got its own strengths and weaknesses. But on the stereo side of things, it's basically like the human eye. So you have 2 cameras, you're looking at the same picture, and then you're doing pattern matching, so edge detections, repetitive patterns, and then you basically compute the depth of every pixel, on the image. And then effectively, when you combine it with an RGB image, you're looking like a human eye, so you're looking at the world in 3D, right? In the case of structured light, a similar concept, but in the sense that you're again estimating depth, but in this case, you're using a projector to project a certain light pattern, and that's going to come back to the camera in a deformed way when it actually hits an object. And then again, complex mathematics, and then you're going to again figure out what is actually going to be the depth of one particular point, of that object. So that's actually structured light. And then time of flight, as the name says, you're basically emitting light, and based on phase shift or the time it takes for light to move, you're actually sort of estimating again the depth, right? Now this is the beginning, and I never contributed to any of these, but the more you read about it, it's actually fascinating how they do it, because there are companies that have taken it to another level. We do it too, which is basically, in the case of stereo, we have what's called active stereo, where you basically, on top of the cameras looking at things, you further shine more light. Basically, that's what we do at the end of the day. You shine more light in a certain wavelength, and then there are more interesting ways of doing it, where you may shine a different pattern at different intervals, and then take multiple images. And there's a lot of innovation, very interesting innovation that's going on in the world. In the same with structured light, you have people do temporal structured light, parallel structured light, and again, the techniques all in a relentless effort to improve your depth quality. That's what we're doing, right? So stereo, structured light, and time of flight are basically the 3 main fundamental technologies that are used in cameras out there, right? The next slide, please. So yeah, we're already to the second part of the presentation, which is about Orbbec and the whole product that we offer. So again, self-explanatory. My 11-year-old would understand what this is all about. So I'm just going to stick to the top left. So established in 2013, we are a publicly traded company, and then I'll just go to the top right, which is what's unique is we manufacture our own cameras, right? So we have a place where we basically assemble the components. You need a clean room to put a camera together, because dust is actually sort of it's going to cause a huge problem for camera performance. So we actually we manufacture our cameras and ship our cameras from our own factory, right? So that's very important. And then of course the rest of the stuff, like I said, it's pretty obvious, and you're gonna get a good feel for who Orbbec is, right? The next slide, please. Okay, so we saw stereo, structured, and time of flight 2 slides ago, and that's what Orbbec does. So one of the very few companies that are doing stereo, on the top right, we do a bunch of stereo cameras. We offer USB, the famous USB, but we also have a GMSL, gigabit multimedia serial link interface, and then we also offer PoE, power over Ethernet cameras for the stereo. Then the structured light cameras are also offered by us. And then the time of flight, we do an ITOF, so indirect time of flight. So again, this is a little subcategory in time of flight. It's called ITOF. We also do those kind of cameras, right? Now, the left part is sort of the crown jewel of what Orbbec does, which is like I said, the math, the triangulation, the pattern matching, as they call it, disparity generation of the depth map. All of that was developed in-house by Orbbec and actually runs on an in-house developed ASIC. So that's what you see on the left side. So all of that is basically chips that are designed in-house, manufactured by TSMC, for example, and all the magic actually then happens in a factory where we put all of that together, and then you basically get a camera in a nice little box, right? One little thing, the ones who are sort of eagle-eyed on the bottom right corner, you see a LiDAR. So yes, we also do a 2D LiDAR, which is basically a DTOF sensor, right, at the end of the day, right? So we also do LiDARs. So it's vision as well as LiDARs. The next slide, please. Okay, so this is sort of this slide is basically we're further condensing our product offering specifically for robotics, right? Because I mean, believe me, our cameras are used for body scanning. There are various use cases where our cameras are used, but just to make it easier for you folks, when it comes to robotics, all the cameras that you see are there at the bottom. The ones that we know customers are using, the ones that is creating a lot of buzz, we know them. And of course, as I said, the LiDAR is something that's going to be very relevant. Now, of course, as a camera maker, it's my wish that there's more people doing visual SLAM, simultaneous localization and mapping. It's not the case. Stefan, who's our next presenter, knows a lot about it, much more than me. But yes, I mean, we definitely see the trend. I've been doing this for 5 years. I definitely see a trend where people want to do more of visual SLAM or a combination. So that's where our cameras are used, can be used. Our cameras are obviously going to be useful for people who want to do obstacle avoidance because the AMR is moving. What many people call machine safety. So it's not people safety, but you're just protecting your own machine, so to speak, your AGV or AMR, which can be a pretty expensive one, right? So that's the one where we're doing machine safety, obstacle avoidance. And then, of course, there's only so much a LiDAR can do. So, and the LiDARs are not looking at a bigger field of view, right? So if you mount a camera at the top, there's a ton of use cases that you can open up, when you have cameras, right, which can do object recognition, right? So that's where your depth and your RGB quality all kicks in, right? And of course, because you do object recognition, our cameras can also be used for stationary robots, right? And the world is merging between mobile and stationary, called mobile manipulators these days. So our cameras can be used for AMRs as well as for a robotic arm mounted on an AMR, for example, right? The next slide, please. Okay, we're already at the last slide. So, but this is a very this is a very heavy slide. I'll start at the top left. There is no free lunch. That's sort of what we're trying to tell you. And I'm just going to talk about sensor and compute because our friend Stefan is going to talk about sensor, compute, and software. So that's his part, right? So what you're seeing here is the work that we have to do. We, as in our engineering in Taiwan and in Shenzhen, for example, had to do to get our sensors working with Advantech compute, right? And Advantech is a massive player in the compute space, right? So it's important to understand that if you're trying to get a GMSL camera, gigabit multimedia serial link camera working, then there's a couple of things you have to do. So on the left side, you will see the camera, the 335LG, two cameras in this case as an architecture diagram. And on the right side is basically where you have the NVIDIA compute, right? Now, here's a couple of things you have to do. Orbbec had to develop a driver which speaks with the driver of the serializer and the deserializer. So that's this little box in yellow color and whatever that color is, cream or whatever, right? So that's the serializer on the camera side embedded in the camera. So that's a bit of design and hardware work. And then there's a deserializer which is embedded inside the compute box of Advantech, right? So first you have to develop the drivers. And then there's a lot of configuration called device management that has to happen. There's this really complicated stuff that you have to do, from configuring virtual channel IDs, sending power on and off commands, and there's a very complicated message sequence chart that you have to follow, right? And then there's this very useful use case, which is you see in the other picture in the bottom right corner, which is basically 8 cameras which are all synchronized. So the power of GMSL is you don't need an external hardware to synchronize cameras, because your NVIDIA SoC is going to send a trigger, and that trigger is going to be grabbed by the deserializer, and then he's going to be able to control individual cameras to actually generate images or synchronize the timestamp, right? So that's a big advantage of GMSL. And again, none of this is free lunch. It was quite an intense work that we did. And what does it mean? For you folks, it means plug and play of the GMSL camera. The GMSL camera driver is pre-integrated into the BSP of Advantech, right? And then time sync across all 8 cameras are actually working without any external hardware, right? So with Advantech on the top right corner, we already did a project with Universal Robots where it's a GMSL camera. It's the easy one because it's 1 camera. And in the bottom right corner is where you're seeing multiple cameras for AMR use case, that we're working together, right? USB is there, but we know USB is not the most beloved interfaces. And like the industry, we are looking to see where you folks are going to pull us. Is it GMSL? Is it Ethernet? Is it AFI? But everything said and done, people like us and Advantech have to work together so that we can give you something that works out of the box, right? So this is the last slide, I believe. So Michelle, I'm going to give it back to you.
Thank you very much, Karthik, for your presentation. I just have a couple of questions I wanted to ask you. So Orbbec does primarily primarily a vision provider. Why do LiDARs?
Yeah, so it's anyone who's in the industry, it's probably obvious, but I'm just going to go back to the basics. So if Giovanni is providing you the brain and Stefan is giving you the algorithm that runs on the brain, and I'm providing the sensors. But we know that we as humans, we have multiple sensors. It's not one sensing modality that works, right? It's more or less the same. I mean, the LiDARs have a certain strength that the vision will never have, and it's the other way around. And LiDARs are indispensable from a safety perspective. So LiDARs are going to be here. Now, if you want to do a safety LiDAR, you first have to learn how to crawl and walk before you run, because safety LiDARs are like running, right? So we started the LiDAR journey where we are currently crawling and walking, ours is non-safety certified. Good news, there are many use cases where even non-safety certified LiDARs are useful. So for us, we already see a very big need for doing LiDARs, which is another DTOF sensor at the end of the day. And we then will have the ability to do sensor fusion between vision and LiDAR. So there's a big vision behind doing LiDARs strategically for Orbbec.
Thank you. Just one more question. Does Orbbec offer samples to customers to test?
Yes. It's a famous one, and I know it's going to come to me at every point in time. So I'm sure again, this is inevitable. We do. It works in a very simple way. I'm going to ship the camera. I'm going to pay. You ship it back. You pay. You keep it for a month, right? If you break it, you pay for it. So we really try to simplify it, because we also totally get it, that people would love to try the camera before they buy it. So yes, we do it. But actually, Michelle, I won't be able to send you a sample because you're based in the UK, and there's some complications in terms of import tax duties. So anything within the EU, I'm shipping cameras all the time to my customers.
Great, thank you very much, and thank you for the offer as well, but I don't know what good I would do with it myself.
Fair enough, I understand.
Thank you so much, Karthik, for your presentation. Yeah. That was fantastic. We are now moving on to our final presentation of the day from Stefan, who will share his presentation before answering some questions from myself, and then we will move on to our fireside chat after that. So, Stefan, over to you.
Thank you, Michelle. Thank you. So very cool. After having heard about amazing products from Advantech, Compute and Orbbec sensors, I'm now happy to talk a little bit about gluing this all together, and also what value and use cases you can get out of it. But before that, I would like to introduce Node a bit and what we are doing for then going into actual use cases. So next slide, please. So who are we? We might not be as famous yet as Orbbec and Advantech, so it's worth sharing a few facts. Node Robotics is a software company that purely focuses on software for mobile robotics. We are based in Stuttgart, Germany. Actually, our location is the Arena 2036. It's a amazing research facility. So if you're around Stuttgart region, just ping me and I'm happy to show you around. We have roughly 25 people in our team, just 5 years old, and what we focus on is making mobile robots really accessible for every company, and leveraging modern software technology to make them really easy to use. Next slide, please. All right, so the problem we see currently and the major challenge for mobile robot OEM is basically building a proof of concept is quite easy. Doing a first pilot is rather easy, but then scaling up from a pilot to an actual production system to a second site to multiple customers is quite tricky. So why is that? It's on the one hand, the integration efforts and customer requests get more and more complicated. And on the other hand, we also see that now having multiple robots in production, you kind of see the long tail of edge cases and problems occur. And this together puts a lot of OEMs in a pretty harsh position where they need to manage these installations. So basically what we see is them being forced into a make or buy decision with kind of the obvious attractiveness of making software in-house with the advantage of tailor cutting to your application, but also being independent of any third-party software. But with the downside that there's typically a quite long go-to-market and a lot of risk and then cost in development. On the other hand, there's of course the attractiveness of buying software, which accelerates the go-to-market, which gives you a industry-ready solution at hand, with the downside of being kind of limited to the offering and to the solution that is offered, and not being able to really adjust it to your actual needs. Next slide, please. Because that's where we come into play. We have built NodeOS for exactly this challenge. So we call it a make and buy solution because it combines off-the-shelf software packages with a environment where our customers can actually continue also building their own applications. So there are 4 key ingredients, which I will briefly explain. On the top row, we basically see the interface part, solving the integration problem, hardware connectors on the one side, so being able to connect to all common sensors, compute, motors, making it really easy to get going. But also on the software interface part, we provide adapters to common periphery systems, WMS, but also agnostic fleet managers. So that's solved with these 2 packages. Now going into the actual application. Here we provide robotics core skills, basically the core functionalities that a mobile robot needs to act autonomously in these warehouse and production sites, and which can be used out of the box. And then we have our do-it-yourself environment, what we call it, where our customers can still build their own behaviors so that they can plug it together and have a complete application. I make an example here. Let's say we have a new application where you need, or we're using a mobile robot to feed a special machine. So with our robotics core, you can already get out of the box A to B navigation. So you don't have to reinvent the wheel here. But typically what's a customized part of this is the interaction with the machine. So how to dock, how to talk to the machine. So in this case, you can use this do-it-yourself environment to build a customized docking behavior that interacts with the machine, which realizes the handover of the loads to the machine, and then kind of the solution is complete. Next slide, please. I want to briefly give you an overview about the already mentioned robotics core packages, so just to show you what's available in here. So it has these two layers, obviously, with the robotics side, with our robot autonomy skills, and the fleet side with our fleet autonomy services. And this is designed in a pretty modular fashion so that our customers can actually choose what they need and still combine it with their internal developments. So on the robot side, it starts with our node localize, which incorporates our LiveSlam technology. Then we have the node move, which includes the localize and gives a full navigation and docking solution. And then when we go from single robots to actual fleets, we provide a bunch of fleet services from map management to traffic management, task execution, and performance analysis. Next slide, please. So this might have been quite theoretical. Let's look into actual applications of our customers. The number here is more than 1,000 robots already using Node OS in production. Actually, this month we just exceeded 1,500 robots. Our major or largest end user is BMW, where several hundred robots are running in several plants. We have already enabled more than 30 mobile robot types with Node OS and are mostly located in manufacturing or logistics use cases, a few service robotics. Next slide, please. So far, this Node OS platform, as I described it, is heavily hardware agnostic. You can plug in different sensors, different compute, different hardware. This is how we designed it. So what's the benefit of now bundling this with certain computes and sensors coming from Orbbec and Advantech? So I would say compatibility is one, but having something that's out of the box, plug and play, and which has proven performance and functionality is kind of the next level when it comes to a fast go-to-market and an easy integration. So that's a strong advantage with this pre-configured and predefined system. But there's more. If we combine our software suite with the Advantech controllers and the Orbbec cameras, it's just the possibility that we have more advanced perception functionality and thereby can apply our solutions to more broad applications and just being more flexible on the requirements is another one. And last but not least, AI is certainly a hype. It's also the most profound technology that's coming. With this bundle, you are future-proof. You know that you can, once the time is right for certain applications to leverage these kind of solutions, you can do it. And this is my final slide. And since there's already a lot of talking about, okay, vision, using vision for AMRs, using AI for AMRs, and there's certainly also some part of it is more of a hype. So the question is, where does it also already make sense to use it? And then this is something I want to show here with 3 distinct use cases where we see already the value of this happening. And the general theme here is LiDAR are the standard sensors for AMRs. They are proven, they have high precision, high reliability, and you can do a lot with them. But they are also limited in a way that the information depth is somehow limited, and certain use cases are just hard to realize with them. So the power here is not choosing a single sensor technology, but actually fuse it, and thereby kind of combine the best of both worlds and having a really powerful setup that can cope with all kinds of conditions. More precisely, we see already a lot of benefit in using cameras in fusion for localization, so visual SLAM, typically in areas where you have low structures, so open areas, but also long flat aisles, a camera that's added can just give the additional robustness and reliability to also cope with these difficult situations. So that's the first use case. A second one, if you are from the industry, a well-known one, the problem of parked forklifts or just like forks in the way of an AMR. The problem here is the forks are so low that the LiDAR typically can't see them. Also, a 3D camera will be hard to distinguish them from the ground. But using vision and AI, it's quite easy to detect the forks and thereby let the robot easily avoid them before bumping into them. That's kind of my second use case here. And third one, where we already see a lot of value, is the whole pallet and carrier detection. So of course, with the LiDAR, you can as well detect the pallet, but when it comes to classify different carriers, when it's about actually looking at the load on top of the pallet in order to make sure that it's rightly packed, then a LiDAR comes to its limits. And again, here, using computer vision and AI, we can quite easily classify different carriers for picking up, for interaction, and then using that information to pick up the right load, to report an alarm if something is not well packed, and use that as an additional information to just make our applications more robust, more versatile, more flexible. Next slide, please. And this is also the end of my presentation. And thank you all for listening. Over to you, Michelle.
Thank you so much, Stefan. I just have two questions for you. How can someone get started with Node OS, and how long does it take to integrate into a robot?
Yes, so we're building upon the robot operating system ROS. So we always say, if you already have a ROS-enabled AMR, so a AMR that has a ROS driver implemented, then we offer the so-called experience package, which is basically a few hours of support and a test trial to get going. And this typically takes a day, where the basic software is installed on the robot, the basic configuration is done, and which already enables interested customers in experience how our software works and what it's capable of. And from that, if the robot is not yet ROS enabled, we also offer implementation services of the ROS driver layer. This typically takes a few weeks, a month maximum.
Thank you. So what are the main benefits of using Node OS compared to other navigation and fleet management solutions on the market? And why should customers choose Node OS over an in-house developed software?
Sure. I mean, I could talk forever about advanced features like our LiveSlam technology, our hybrid HEV AMR mode. But in the end, I would say the following three, and actually it's the combination of the three. It's one, it's industrial proven, so it's running on more than 1,400 robots, which is really crucial to have that check. So it's actually reliable in industry, combined with the ease of use. So we really put high efforts in making our software really easy to use with intuitive user interfaces, but also with the autonomy behind the user interfaces, which kind of helps getting rid of a lot of integration efforts. And last but not least, our system is not a black box. It's an open system based on ROS, and this enables this make and buy attribute that I mentioned, which helps our customers to really fine-tune and customize for their needs. And I think the combination of three is pretty powerful.
Great. Thank you so much, Stefan, for your presentation. And thank you all for your presentation so far. We're now shifting on to a more relaxed but still content-rich segment of today's webinar, a fireside chat with our panelists. We've got a few questions lined up. for us all to explore our thoughts further and connect the dots between your presentations. So first question, looking ahead, how do you see the role of AI accelerators like NVIDIA or evolving in AMR development? Giovanni, might you be able to answer that one?
Yes, I think that NVIDIA Orin acts as really a powerful brain, let me say, for AMRs. So providing the necessary computational horsepower to process complex AI algorithms in real time. So leading to smarter, more adaptable, and more capable robots. So in general, as AI models become more sophisticated and demand for autonomous solution grows, AI accelerators like the Orin will be key for, let me say, pushing the boundaries of AMR capabilities. Yeah.
Thank you very much. What are the most common obstacles you see in current AMR developments across industries?
Is this for me?
For either of you guys, whoever
okay.
feels ready to answer.
I can also take it, Giovanni, if you want.
Yeah. I mean, in general, I would start saying, let's say, clear return of investment by end customer in general, in my opinion. This is one of, let's say, implementing a robot to replace humans brings a big impact, investments, different work methodology, and related processes, but also regulatory compliances. So mainly for safety reasons. So I believe that in general, today we have the suitable hardware, software technology to build a reliable autonomous robot, but we will need still 3-5 years before to have a general acceptance by humans in order to see a massive robotics implementation in many industries. Yeah, that's my opinion.
Yeah, I would agree. That's definitely the case, but I would even add a second part to it. So the right ROI is important for a project decision. Then if a project has been decided for execution, what we see is typically the obstacle of high integration efforts. So it takes very long. And then also the reliability. So it's again a bit duplicated from my presentation, but the stage at where the robot's running productively with the right reliability usually takes a long time, which then again kills the ROI and also makes the end users more hesitant to deploy more.
I agree.
If I may finish it off. So for me, you're absolutely right. We see it all the day. What I feel is a problem is the skill set at AGV manufacturers or where they go and deploy the robots, and there's a skill set there which is actually not matching with what is required to fine tune a compute or a software or a camera, right? I mean, even for the camera, I learn new things every day, literally every day, and fine tuning camera parameters and performance, and software is even more complicated than hardware, like an AGX Orin and configuring and offloading and optimizing code for the CUDA, whatever. It's all complex work that has to happen, right? So that's, I genuinely feel that even if you were to give the best camera, you still need to train the people to use the camera. It's a tool at the end of the day. So that's one part where, I feel like we could move a lot faster if the skills are available in general, and that's on the vision side. I stumble upon that all the time, right? And of course, on a second lighter note, I think LinkedIn should ban all robotic videos for 6 months, and then everyone will do the real work, and then I think we will probably move faster, because it's just so much hype. And that hype doesn't help, and that hype is definitely not helping because people set the unrealistic expectations, and that just slows us down as an industry, which I think we all should probably take a good look at that.
Thank you very much. So we are running out of time, so I've just got a couple of more questions before we move on to our questions from the audience. So just one more question for the fireside chat. What does a strong robotics ecosystem mean in practice, and how are your companies contributing to that?
Okay. Yeah, I think that we have already in place with Node and Orbbec as in place a lot of activity, also planning a number of co-activities with our partners here. But in general, I would say the connection between R&Ds, so the research and development departments, the hardware and software integration, so validation, the compatibility between the two, hardware and software, and sensors, hardware and software integration also. And also to have specific investments, like an example in marketing or co-exhibition at vertical events, so mutual trainings. These are, I mean, some examples to strengthen partnership relationship, in my opinion. Yeah.
I'll just make a quick comment. I think what I know Stefan is doing, and we're doing it too, belting out ROS compatibility is a big deal. So we do ROS2, Jazz, and ROS1, Novatic, rest in peace, ROS1. But doing something on a ROS is definitely very important for the ecosystem, right? And then together giving them tools, out of the box experience, making it easier to fine tune everything, software to hardware to sensors, is something where we all work together. It's tricky because sometimes my partner and another partner are competing, so it's a very tricky situation. But we all figure out what are the strengths each partner can bring to the table, and then you play to your strengths. Right?
Yes, I would agree in that. The compatibility between the different components, there are so many different components that have to work smoothly together, and a ecosystem where the people actually building robots can make sure that if I take that part and that part, it works well together, and I don't have to spend like a year of development in my team. That's really king, and ROS is driving it. And but it's actually more than ROS. It's also each company contributing, making sure that it stays compliant, that it works together, it keeps up with the current advancements. So it's really out of the box. I guess that's key.
Thank you all. We only have a few minutes left, so I'm going to open the floor up to our audience. This has been a fantastic conversation so far. So first questions that has come through. With so many technologies in play, AI, vision, edge computing, autonomy, how should AMR manufacturers prioritize their tech stack decisions?
Okay, I'll go first. This is the tricky thing with these. So I think it's honestly pre-validated, pre-integrated. It comes with a price because people are going to be like, oh, then I'm going to have less control over it. Yes, this is a fine balance. But I think anything that is proven on the field, anything that's out there that is actually shown to work, is obviously going to accelerate time to market. So you may pay a premium for that, but then think about it. Do you want to spend hours and hours trying to develop something in-house? It's a very tricky situation because people in startups are normally very proud and they want to do everything internally. We totally get it. So it's a balance that they will have to figure out. But rest assured, it took us months to get our GMSL driver working with Advantech compute. So nothing is for free, and that has to be appreciated. And people do appreciate it.
I would add, like, if I put my shoes in one of the customers, then I would first analyze what is actually needed, like which application am I designing my robot for, what kind of capabilities do I need, because of course there is already a lot of technology out there, but it's not always needed for everything. So there is of course a value in keeping it simple, if it's possible, if the requirements give you that possibility, and then really selecting the right components to fit these requirements. This of course needs some experience, but there are also good references, and I think also in the companies presenting here have got knowledge about it. So happy to just reach out if you are in such a situation. We can help also with our expertise here.
Thank you very much. Next question. How do each of your technologies come together to reduce time to market for AMR manufacturers? Who'd like to go first?
I mean, I made my main pitch about this go to market. I think I don't have an official number though, but I think the software development is probably the one that takes longest in the whole development journey of an AMR. And this can be so much accelerated if you don't have to reinvent the wheel, if you don't have to rebuild everything from scratch. And this is exactly what we are offering with this modular software solutions, where you can say, okay, I need this functionality, I can buy it off the shelf and then focus on a certain part that's maybe unique, that you need for your application.
And from a hardware point of view, as a hardware manufacturer, as I said, we have a very focused product division that is targeting, of course, tailored hardware solution in order to meet the needs of robot manufacturers. So we provide, in general, the right feature, we think, and also a broad selection of architectures. This webinar was really focused on NVIDIA solution, but as Advantech, we have the possibility, say, to work with, since we work with the main silicon vendors, to offer a broad selection of AMR controllers, so ready for, or let's say, almost ready, let's say, for testing and easy integration inside the computer solution, inside the robot solution.
Thank you. Karthik, maybe you might be able to answer our next question from the audience. This is from Pavo. Which ROS versions are currently supported?
Yep, I've seen the question, and I think it's maybe for Stefan too. So we support ROS2 and ROS1, ROS2 Jassy, and then ROS1 is Noetic. So that's what we do, and we give a ROS1 and ROS2 wrapper. And I think, Stefan, you probably will also want to chip in.
Sure, but it's basically the same. So ROS1 goes end of life. We still support it, but all the developments happening in ROS2. ROS2 chassis is our currently supported ROS version.
Thank you. One last question. Is the risk assessment system embedded with the path planner, or does it work independent of the path planner? Who might be able to answer that one?
I think that's also for me. Happy to answer that. So we take the safety into account for computing the local paths, so that we make sure that our paths and motion commands are safety compliant. Having said that, there is still kind of this independent safety layer underneath our stack, which really makes sure that that in the end the robot is carrying out these commands. So that means it's integrated, but in the end there is still a safety layer. So our stack is not responsible in the end for assuring the safety.
Great, thank you guys so much. I think that's all we have time for. That brings us to the end of this webinar. A big thank you to our guests today, Giovanni, Stefan, and Karthik. If any of our audience would like to rewatch this after today, it will be available on demand on the Robotics and Automation magazine news site very soon. So be sure to check that out. Thank you guys so much for today, and goodbye.